right, so we're going to expand our techniques for doing integration. So we're going to use a rule here that basically kind of reverses the product rule. So use substitution, reverse the chain rule, and this is going to be a method that can kind of reverse the product rule. The key is there is actually not a product rule for integration, okay? But this is kind of the closest thing that we have. Either the use substitution where you have something times its derivative, so that's a product, so to speak, or this technique. Okay, so we're going to actually go through and develop the formula for integration by parts. So we're going to look at this product rule, and then we're going to integrate both sides. So in our product rule, I'm going to leave a space here. Okay, so that's the product rule. First times, or u prime, we're writing it a little different order, but derivative of one times the other plus the other one times the derivative of the other one. Doesn't matter, that's your rule. So now what we're going to do is we're going to integrate both sides so that we can see what happens. So if we do the left, if we do the integral of the derivative, you're going to end up with uv. And then on the right-hand side, we're going to get that we're going to split this. So we're going to have the integral of u prime v dx plus the integral of u v prime dx. And then what we're going to do is we're going to solve for the way that we're going to end up writing it, which is this. So this is how we're going to set things up in order for it to work. So we're going to actually solve for that. So we're going to have the integral of u v prime dx is going to equal uv minus the integral of u prime v dx. My primes are kind of crazy. All right, so this is the formula. So it's there in the box, and it's definitely something you have to memorize because when you need it, you just have to know it, okay? So this is the way that I would suggest that you'd learn it, and this is the way we'll kind of always say it. So the integral of u dv is equal to uv minus the integral of v du. Now, in order to figure out how to set it up, I'm going to do some examples, and then we're going to talk about how we can set it up. And so there's helpful strategies for how to choose u and v that are written, but that'll actually make more sense to go back and read those sort of last. So they're there. So we're going to go ahead and do some examples, and then we'll refer back to how we decided to do that. So in this example, we're integrating x e to the x dx. Every single integration problem you will ever do in your whole life, the first thing you should always do is go through the process. So the first thing is this a formula? No, this is not a formula that we have. Next thing is, can we do u substitution? So u substitution would normally be, can we let u be the inside of one of the functions? And if we do, are we multiplying by its derivative? Well, you can see pretty quick here, we're not going to have that. So next thing we're going to try is we're going to say, okay, it's a product. So I don't have a product rule, but integration by parts might work. And so I'm going to let something be u and the other part's going to be dv. Well, so what I'm going to do here is, normally the thing that we pick for u, this is not set in stone, but we usually pick the thing for u that when you take the derivative is going to go away. And you'll see as we do examples how that makes more sense. So I'm going to let u equal x, and dv then is going to be everything else, which is e to the x dx. Okay, so those are the things that I am picking. So there's u dv. So basically I've got right here, this is u, and this whole thing is dv. So I've now rewritten it as u dv. So the integral for u dv, if you look at the product right, or the formula right there that we circled, is going to be u times v minus the integral of v du. So that means I have to find both v and du. Well, you find those simply by doing what it says. So here I have u equals x. So the derivative of u is du. The derivative of x is dx. Okay? Then on the other side, I've got dv is e to the x dx. I need v, which means I need to integrate it. So the integral of e to the x is just e to the x. Now we don't worry about the plus c's here because we're just going to add plus c at the very end after we're done. So now what I'm going to do is I'm going to follow the formula. So the formula is if I have uv or u dv, then the integral is going to equal u times v. So u times v, so x e to the x minus the integral of v du. So that's e to the x dx. Okay, so look carefully here. It's uv minus integral of v du. And that's exactly what we've done. So I chose what's in red. I have to make the original problem equal u dv. And then once it does, everything else just sort of falls in place. So now what will be left to do is to integrate the second part. The beginning is done. X e to the x is already integrated. And then I just have to integrate what's left, which is e to the x. So I get e to the x. And then here's the point where I'm going to add my plus c. And that's the answer. All right, so let's do another one. And so again, the more that you see, this is one of those things definitely, the more that you see, the more that it will make sense. You just have to kind of look at a lot of examples and then it'll start to make sense. Now, for this one, it looks like we don't have a product. We have ln of x, and we don't have anything else. Well, we do have a product still because we do have ln of x times 1 dx. So we have to pick one of those things for u and one thing for dv. Well, we certainly can't pick ln of x to be dv because then we would have to integrate it to get v, and we don't know the integral of it. That's the whole point. So we're going to let u equal ln of x. Now, if you look at if we go back to the guidelines here, you will see that, and this is one that I like to use. Again, it's never perfect. It's just like u substitution. Most of the time we try this, okay? So you're going to use liate, liate, or whatever you want to, however you want to remember it. And so the first thing I choose for u out of this list would be a logarithmic. And then I would choose an inverse trig function, an algebraic, trigonometric, and the last thing I would ever do is exponential to be the u, okay? So that means, following those guidelines, I'm going to let u equal ln of x, which means dv equals dx, because I have to completely substitute for that entire integral. So I've now substituted, this is u and this is dv. So I've just done u dv. So I've substituted. So now I'm going to go through and I need to find the other parts. So if u equals ln of x, then the derivative of u is du. The derivative of ln of x is 1 over x dx. Then I have dv equaling to dx. So if I integrate that, I'm just going to get x. So using my formula then, I'm just going to go through and the formula says do uv and then it's minus v du. So uv, I wrote it v times u because that's the order we would do it in. uv minus the integral of v du. And you just write what it equals to. So then before I integrate, I'm going to go ahead and simplify this. This is actually x times 1 over x, so that's just 1 dx. Now I can finish. This is x ln of x minus the integral of 1 dx, which would be x plus c. So This is a really, really good one because it doesn't seem like it should be integration by parts. So this is kind of one of those star type problems. Like really pay attention to this because you're going to see it later in a problem where it's the way we would do inverse trig functions also. We do the same kind of thing. This one is probably one you could even add to your formulas if you wanted to memorize it. So those of you that are really good at memorizing may want to just memorize that the integral of ln of x is in fact x ln of x minus x plus c. Okay, so let's do another one. Now, if I do definite integrals, and this is something that we have to pay very careful attention to and what some people have missed before is you have to pay attention that these limits of integration are for x. So my problem needs to keep everything written in x. If I wanted to change it to be written for u and stuff, I would have to change the limits of integration. Now this technique doesn't actually call us to do that, so it's not that big of a deal. And basically you just do the whole definite integral and then at the end you plug stuff in, or whole indefinite integral and then plug stuff in. So the process will be the same. So first thing is this a formula that I know? It is not. Is it going to work with u substitution? If I were to let u equal minus x, the derivative would just be -1. I have an x outside. That doesn't really work, so we're going to try integration by parts. So following the Liate, then algebraic would come first, and that would be what I would choose for u. I'm going to try to keep always doing those in red. So I would choose x for u, and that means dv would be everything else that's left, which is e to the minus x dx. We're not always going to know exactly what to choose. We're just going to try certain things, just like u substitution. You just kind of learn from experience, and then, you know, sometimes it doesn't work, then you try something else. All right, so if u equals x, then du is going to be dx. If you take the derivative, dv equals e to the minus x dx. So if we integrate e to the minus x dx, we're going to get e to the minus x and then divided by -1. So we can just put -1 in front. So to do a definite integral, I still write uv minus the integral v du and all that. I just have to watch for the 0 to 4. So uv, so again, going this way, uv is going to be minus x e to the minus x. The difference is I need to put here 0 to 4 because I actually need to evaluate that. And then it's going to be minus the integral, which now has to have limits of integration, minus the integral of v du, which will be minus e to the minus x, so that's going to end up making this plus e to the minus x dx. If you want to, you can write that it was minus e to the minus x, which is why I made that plus. And that would be plus, okay? But I like to just fix the plus sign when I know that, fix it to make it a plus sign. Now again, because you're writing this is absolutely required on every problem no matter what. You must write down what you're substituting. And because you write it, it does make it really easy to do the problem because you see it right there. Okay, so now all I'm going to do, I'm not going to plug in 0 to 4 on the first one. I might as well just wait and plug it in on all of them. So I'm just going to write down what I have at the beginning, and then I'm going to integrate e to the minus x, which again will be minus e to the minus x, and then we're going from 0 to 4, so now we'll just plug it into all of it. So we're going to get -4 e to the minus 4 minus e to the minus 4 minus parentheses 0 minus e to the 0. So be careful when you plug stuff in that you don't assume that the whole right hand, you know, everything becomes 0, because it's not. So we have -4 e to the, oh, well, these are like terms right here. So we have actually -5 e to the -4. And then you have minus a negative, which means plus e to the 0, which is 1. And so this is my final answer for that problem. Okay. So now we're going to do another one that has integration, that has a product that uses integration by parts. So here again, I have to decide what am I going to let u equal. So you might think to yourself, hey, u should be x cubed because that's what we've been doing, and then that one kind of gets easier. The problem is that would mean that dv has to be the log function. So think liate, which tells me the first choice for u should be the log function. So I'm going to let u equal ln of x, which means dv is the rest of it, which is x cubed dx. Okay, so you're going to have what's left. Now I need to find du and I need to find v. So if u is ln of x, then du is 1 over x dx. If dv is x cubed dx, then v, I just integrate it, is going to be x to the 4th over 4. And then remember, we deal with the plus c over here, okay? So that's going to give me, now once I make these substitutions, once I fill all this in, don't worry about the original problem. Just do what you're supposed to do. uv minus the integral of v du. That's what you do. So we're going to have 1/4 x to the 4th ln of x. Now the reason I could write that nicely is because, again, I see it right here because I wrote it out, so I can sort of get the order written correctly. You always want ln of x to be last. Minus the integral of v du. And then we need to remember we're going from 1 to e, so we need to write that in both places there so we don't forget to do that. So again, I'm not going to plug in that stuff now because I'm getting ready to integrate the other one. Actually, it's going to need a second to do that. We'll do it in 2 steps, but you could probably have done that in your head. But you're going to end up with 1/4, which I'm going to write in front of x cubed dx, because x to the 4th over x would be x cubed. And so again, now we're ready. So we have 1/4 x to the 4th ln of x minus 1/4 times x to the 4th over 4, if we integrate x cubed, and all of that is 1 to e. So first we plug in e, so we're going to get 1/4 e to the 4th, and then we'll have times ln of e. Well, ln of e is 1, so that's not going to have anything there, and then it'll be minus e to the 4th over 16, because I'm going to multiply together my 4 times 4, and then I'm going to have minus parentheses, and I need to plug in 1. So I'm going to have 1/4 of 1 to the 4th, but then I have times ln of 1. So right here, when I plug in the 1, I'm going to get 0. So that product will be 0 minus 1 over 16. And so I have 2 like terms here. I have a 4th e to the 4th minus e to the 4th over 16. So they need a common denominator. So make yourself have a common denominator. So we get 4 e to the 4th minus 1 e to the 4th over 16. So that's 3 e to the 4th over 16 plus 1/16 because you have minus 1 over 16, minus a negative 1 over 16. And that would be the answer to that one, okay? So remember, if this was the free response question on the AP test, you could just stop there. You wouldn't have to simplify more, but we need to practice because, you know, again, multiple choice matching and all of that. Okay, so now we're going to do another one of those that looks like it's not actually a product, but in fact, it will work by integration by parts. So we have arctangent of x. So again, first thing I do is I say, all right, is that a formula? Well, no. I know how to integrate something and the answer's arctangent, but I don't know the integral of arctangent. So I'm going to let u equal arctangent of x. That means that dv is going to equal just dx because that's what's left. Then I need to find du. So again, u equals arctangent of x. The derivative of arctangent is 1 over 1 plus x squared. And then dx. dv equals dx. So if I integrate dx, I get x. So here is my stuff that I need to substitute. Now I'm going to do my process. So it's going to be uv minus the integral of v du. So it's going to be x arctangent of x minus integral of x over 1 plus x squared dx. Okay, so if I multiply x times 1 over 1 plus x squared, I'm going to get x over 1 plus x squared. Now, for every integration by parts problem, after you get to this integral that ends up over here on this second part, you have to do whatever it takes to integrate that. Sometimes it might be integration by parts again. Sometimes it's u substitution. Sometimes it's a formula. Sometimes it's a power. It's whatever it is, you have to figure it out. So we're going to have to go through our process here. So our process is this a formula? Well, x over 1 plus x squared is not a formula. So then we try u substitution. So remember that when it's a quotient, we kind of look, can we do du over u? Is that possible? So that would mean I want to let u equal. Now, this is a different u. Okay, so it's why I even boxed that other one in. This is a u substitution for this problem. We're going to let u equal 1 plus x squared, which means that du equals 2x dx. So I can make it du over u. I just have to fix it. I have to put a 2 here and a 1/2 out front. Now I do have du over u. Okay, so now I can integrate it. So I have x arctan x, that's already done, minus 1/2, and it's du over u, which is ln of the absolute value of u, and then it's the whole thing plus c. Remember, this 1/2 comes from here. Now, I don't actually have to have the absolute value bars here, so don't forget that if you're checking for multiple choice, for example, because 1 plus x squared will always be greater than 0, and so I don't have to have them there. Okay, I'm going to do one more example, and then we'll do the rest of them in class. So let's do e to the square root of x. So, process for every integration problem. We would say, is this a formula? This is not a formula. So then we're going to say, okay, well, can I do u substitution? Well, if I did u substitution, I would have u is going to equal the square root of x, and then the derivative would have to exist there. Well, what we're going to do for this problem is we're going to do something different. We're going to use integration by parts in a little bit. But before we can get there, we're going to try to do a u substitution, because right now it's not really a product, so I'm not going to be able to do anything with it. So what I'm going to do is I'm going to say, let's let u equal the square root of x. So that does get me this substituted for. But if I were to do the derivative as it's written, I'm going to end up putting in a 1/2 x to the negative 1/2, and I don't have that. So a technique that you can use sometimes, and this is a good example of one of those to kind of take note of, is remember that I just have to get everything substituted for. So I might need to rewrite things. So I'm going to square both sides so that I get that u squared equals x. And now I'm going to do the derivative, and you're going to see that there's going to be a way for me to do this problem then. So now when I do the derivative, I get 2u du is going to equal dx. And the key here is, do I have everything substituted for? Dx, dx. So this will be instead of dx. And then I have e to the square root of x, and square root of x equals u. So I will be able to substitute everything and have the problem be only in terms of u. So that's going to make it the integral of 2u e to the u dx, or du, sorry, du, okay? Because I put 2u du instead of the dx, so that's what was in blue, and then the square root of x is a u. So now my entire problem is in terms of u. Well, now the deal is, now I have kind of a product. So now I got to go to this u substitution right here to do that. So what I do is I just mark this off. Now I could have used different letters. I just don't stress over using u again. I just need to remember these u's are finished. Okay? So the difficulty is going to be my problem now has u's in it. So if I let u equal something, it's going to be confusing. So instead of doing that, what I might want to do is just go through here and say, okay, wait, instead of u, let's just use w. So I'm just going to take the u's and make them w's, because just remember, it doesn't actually make any difference what letter you're using. We're just holding a spot for things. So instead of u equaling square root of x, really it was w equaling that. And you can change it over here in this box over here if you want to, or you can just leave it and just change it over there to make sure they're different. All right, so now I need to think about, okay, can I do integration by parts, because I have a product here. Because I have w, or 2w, times e to the w. So think of our choice for Liate, tells me do logs, inverse trig functions, algebraic. So algebraic we have 2w. So we're going to let u equal 2w, which means that dv is the stuff that's left, which is, and I'm going to have to move this over, is dv is going to be e to the w dw. Okay, so that's going to be the part that's left. So I do the same thing. If u equals 2w, then du equals 2 dw. If dv equals e to the w dw, then v equals e to the w. And then I do the same thing. I go u to v, so uv minus v du. So this is going to equal uv is going to be 2w e to the w minus integral of 2e to the w dw. So this is 2w e to the w, and this is minus 2e to the w, because when you integrate it, you just get the same thing, plus c. But that answer doesn't make sense because I substituted stuff. So remember, this was actually w, because I started to use u, but then realized, hey, that's confusing. So change all those to w's. So that means when I write w, I actually want to write square root of x. So this is actually 2 square root of x, e to the square root of x, minus 2e to the square root of x, plus c. And that's going to be my answer. And I just have to make sure that I substitute back to have the same thing that I started with. Now, this stuff is a little bit confusing. So don't expect that you should be able to figure it out immediately. I would go back and watch some of these again, and go back and watch. Now that we've done several of them, go back to the first example, watch the video again, go through the process again. It will start to make more and more and more sense. And then in class, we'll finish up the last part of the notes. But I would strongly suggest you go through this video a couple of times in order to better understand what's going on. And so that's it for this video.